In this video, we'll be looking at Chapter 14, Section G.2 on modulus equations. Remember from the last video that we defined the function, the modulus function, which is f of x equals the absolute value of x. And we graphed the modulus function. We looked at some of the properties of the modulus function, and we got comfortable working with plugging numbers in and simplifying or evaluating the modulus function. So really quickly, I'm going to write down some of the properties of the modulus function. And these are properties that hold true for the modulus for any number, for any real number. So the first is that we have the modulus of x, or the absolute value of x, is never negative. So no matter what real number I put in here for x, I can never get a negative number out. In other words, another way to write this is that the modulus function is always greater than or equal to 0 for all x. Next is the absolute value, or the modulus of x squared, is equal to x squared, again for all x. And you can see that this is true, and we know that squaring any number, positive or negative, is going to get us a positive number. So this property always has to be true. We can also prove, and I won't take the time here, that the modulus of x times y is equal to the modulus of x times the modulus of y, again for all real numbers x and y. The next property is very similar. The modulus of x divided by y is equal to the modulus of x divided by the modulus of y. The only restriction on this case is that y cannot equal 0, because we can't divide by 0. And then the last property that I'm going to show you is the modulus of a minus b is equal to the modulus of b minus a. And again, this is true for all numbers a and b. One thing that's not true, and I'll show you really quickly, is that a plus b, the modulus of a plus b, does not equal the modulus of a plus the modulus of b. And for example, if a was negative 3 and b was 5, you would see on the right hand side here, or I'm sorry, the left hand side, that I would have a modulus of 2. And on the right hand side I would have the absolute value of 3 plus the absolute value of 5, and this is 8. So these do not equal each other. That is not one of the properties that you should remember. We're now going to take a look at equations that include the modulus or absolute values. Let's start with a really easy example. We have the absolute value of x equals 2. Well, hopefully you can see right away that x has to equal 2 or negative 2, and these are my only two solutions. So in general, if the modulus of x equals a, and a is greater than 0, then x has to equal plus or minus a. And this is exactly what we saw in the example above. So I'm going to quickly walk you through the proof of this general statement. So we know that if the absolute value of x equals a, then we can square both sides to get the absolute value of x squared equals a squared. Well, from the properties that we talked about in the previous slide, we know that x squared therefore has to equal a squared. Do a little bit of rearranging. We get x squared minus a squared equals 0. Do some factoring here. So therefore x minus a times x plus a equals 0. And what we have for a solution then is that x equals plus or minus a. And so here's the proof of this general statement above. And we're going to use this fact in the coming examples to solve equations that include the modulus. So in this example, we're asked to solve for x, and we're given the equation the modulus of 2x plus 5 equals 1. So remember from the previous slide that whatever's inside the modulus, which in this case is 2x plus 5, has to equal the positive or negative of whatever's on the right-hand side of the equation. So in this case, we see that 2x plus 5 has to equal plus or minus 1. So what we're really doing here is solving two separate equations. We have 2x plus 5 equals positive 1, or 2x plus 5 equals negative 1. And these are two simple algebraic equations that I can solve. I get 2x equals negative 4, or x equals negative 2. And for the right-hand equation, I get 2x equals negative 6, which means that x equals negative 3. And so I get two solutions here. And when you're solving these types of equations, you should be looking for two solutions when possible. And sometimes you won't get two solutions, and sometimes you won't get any. So let's take a look at an example of that. So in this example problem, we're again asked to solve for x, and we're given the modulus of 2x plus 5 equals negative 2. Well, if you remember the condition from our general statement, which said if x, the modulus of x equals a, where a is greater than 0, then x equals plus or minus a. This is really important condition here, and it's a property which I showed you on the first slide of moduluses, that a modulus can never equal a negative number. So there's no number I can put in here for x that's going to turn this function, this modulus, into a negative. Therefore, this question has no solution. And remember, no solution is a valid answer in math. Sometimes you just can't do what you're being asked to do.